Introduction. Why are you looking at the clock, Vijay?
I am trying to make out the angle made by the hands of the clock, uncle.
I see. So what angle do they make, Vijay?
They make a right angle, uncle.
Great! Can you also comment on the shape of the clock, Vijay?
Sure. The clock had 6 sides and it's a hexagon.
Wonderful, Vijay. You have learnt your geometry well. Children, in this lesson, you will learn the basics of geometry. Objectives. At the end of this lesson, you will be able to differentiate among lines, line segments, and rays. Identify right, acute, and obtuse angles. Measure angles with divider and protractor. Line segments, lines, and rays. Rahul perfects his aim by throwing darts at the dartboard. Here is one such dart. Let us remove it. What do we observe? The dart has left a mark on the dartboard. The mark is called a point. A point has no dimensions. It has no length, breadth, or height. Let us remove another dart to reveal another point. We name the 2 points A and B. We now join the 2 points. We get the line segment AB. A line segment has a definite length. It has 2 endpoints. Can we draw another line segment between 2 points A and B? No. Only one line segment can be drawn between any 2 given points. Look at this thin strip of rubber. Let us nail it to the wall and name the point C. The other end of the rubber is free. Let us stretch it. First a little, then a little more, and then some more. What we get is a ray. A ray has only one end point. It can be stretched in the opposite direction infinitely. Let us now remove the nail and stretch the rubber in other direction. We now have a line. A line has no end points. It can be stretched in either direction infinitely. Polygons. We can form different shapes by enclosing them with line segments on all sides. Such closed figures are known as polygons. Polygons have different names depending upon the number of line segments they use. Here we look at the following types of polygons. They are triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Now we will learn more about each polygon one by one in details. We take 3 pieces of plastic and join them to form a towel hanger. We have created a triangle. A triangle is a polygon made up of 3 line segments. It is the smallest polygon possible. We use 4 pieces of carved wood to create a photo frame. We have created a rectangular photo frame. A rectangle is a 4-sided polygon. It is made up of 4 line segments. Look at this image of US Army headquarters. It is known as Pentagon, as it has 5 sides. A 5-sided polygon is called a pentagon. Here is a clock. Let us provide its borders. We have a border of 6 line segments for the clock. A hexagon is a polygon made up of 6 line segments. Let us create a wall hanging using 7 straws. The rainbow wall hanging with 7 line segments is ready. A 7-sided polygon is called a heptagon. This is the image of the ceiling of a chapel in Germany. It has 8 sides. An octagon is an 8-sided polygon. Look at this image. It is the Bahá'í's house of worship. All Bahá'í's house of worship have 9 sides. A nonagon is a polygon made up of 9 line segments. Here is an old $5 coin from Hong Kong. It has 10 sides. A polygon with 10 sides is called a self-assessment. Match the items of column A with the items of column B. Self-assessment. Drag and drop the correct options to fill the blanks. Angles. Any 2 adjacent sides of a polygon form an angle between them. An angle is the space between 2 lines, line segments, or rays that move away from one another from a common point. The measure of an angle is specified in degrees. Let us take a look at 3 types of angles. They are right angle, acute angle, and obtuse angle. Now we will learn them one by one in details. Look at this scene. In this, a ladder is standing with the wall. Let us look at 3 angles. First, the angle which the wall makes with the ground. Second, the angle which the ladder makes with the wall. Third, the angle which the ladder makes with the ground. Let us begin with the angle that the wall makes with the ground. The ground acts as the base and the wall as the vertical line. The angle is L-shaped. It is a right angle and its measure is 90 degrees. Now consider the angle that the ladder makes with the wall. We take the wall as the base. The ladder is not vertical. It is tilted in. Such an angle is called an acute angle, and its measure is less than 90 degrees. Now let us look at the third angle that the ladder makes with the ground. We take the ground as the base. The ladder is not vertical. It is tilted out. Such an angle is called an obtuse angle, and its measure is more than 90 degrees. Measurement of angles. An angle is measured in degrees. Let us now measure angles with 2 different instruments: a divider and a protractor. Look at this object. It is called the divider. We can use it to measure angles. Let us see how. Write letter L of the English alphabet. Place the divider on L and adjust it to coincide with L. Lift the divider up. The angle formed by it is a right angle. Write letter V of the English alphabet. Place the divider on V such that one of its arm and common point coincide one of the arms and common point of V. What do you see? The other arm of the divider lies to the left of the other arm of V. It means that V makes an angle, acute angle, which is smaller than the right angle. Now consider the letter K of the English alphabet. Let us modify it to look like this. Place the divider on the figure such that one of its arms and common point coincide with one of the arms and common point of the figure. What do you observe? The other arm of the divider lies to the right of the other arm of the figure. It means that the figure makes an angle greater than the right angle, that is, an obtuse angle. Therefore, we can measure a right angle, an acute angle, and an obtuse angle with the help of a divider. The wider the divider opens, the larger the angle it makes. Protractor. Protractor is a semicircular geometric instrument. It has degrees marked on it from 0 to 180. Let us measure the angles made by the hands of a clock with the help of a protractor. This clock shows the time as 3. The long hand of the clock is on 12 and the short hand is on 3. Place the protractor on the short hand of the clock. The horizontal line at the bottom of the protractor must coincide with it. The midpoint of the protractor must rest on the common point where the long and short hands of the clock meet. Read the inner marking of the protractor on which the long hand rests. It is 90 degrees. Therefore, 3 o'clock makes a right angle. This clock shows 20 past 6. The long hand of the clock is on 4 and the short hand is on 6. Place the protractor on the short hand of the clock. Read the inner marking of the protractor on which the long hand rests. It is 60 degrees. Therefore, the time 20 past 6 makes an acute angle. The time is 10 past 9 by this clock. The long hand of the clock is on 2 and the short hand is on 9. Place the protractor on the short hand of the clock. Read the outer marking of the protractor on which the long hand rests. It is 150 degrees. Therefore, the time 10 past 9 makes an obtuse angle. The angles made by the hands of a clock can be worked out without the help of a protractor, because space between any two numbers measures 30 degrees. By this logic, we can measure 3 o'clock as 30 degrees multiplied by 3 is equal to 90 degrees. 20 past 6 as 30 degrees into 2 is equal to 60 degrees. And 10 past 9 as 30 degrees. Self-assessment. Hey kids, it's time to recall what you have learned. Drag and drop the correct measures on the marked angles. Summary. Let us summarize what we have learned. A point has no dimensions. A line segment has two endpoints. A line has no endpoints. A ray has one endpoint. Right angle measures 90 degrees. Acute angle measures less than 90 degrees. Obtuse angle measures more than 90 degrees. Angles are measures with the help of protractors and dividers.